Hey everyone, so we're going to continue our discussion with logs, and we're actually going to talk a little bit about laws of logarithms. So before we do that, let's refresh our minds with the laws for exponents. So if we scroll down, here we have x squared times x cubed. Remember, when we have a scenario where we're multiplying two terms with the same base, we're going to add their exponents. So this becomes x2 plus 3, which ends up being x to the fifth. Over here, now we're dividing it. So division is the opposite of multiplication. So we're basically going to do the opposite of addition, which is subtraction. We're going to subtract 2 minus 3 and get x equals -1. Now, we don't like that negative, so we're going to rewrite it as 1 over x. Over here, we have two exponents on the same term. So what we're going to do here is actually, we're going to multiply these two numbers. So this is going to be 2 times 3, which is x to the sixth. So again, depending on how we're dealing with these two terms of x squared and x cubed, whether we're multiplying or dividing, it changes how we're going to deal with their exponents. We can either add the exponents, subtract, or multiply them. Down here, now they want us to simplify these terms, and they want us to use rational exponents. For this first one, there's actually a few ways I could go about doing this. I think the way that I'm going to want to do it is to first take the square root of 4. So I'm going to end up having this. Taking the square root of 4 just makes it into a 2, pulls it out of the radical. So I have 2 radical x. Don't like that, so I'm going to replace the square root on x with an exponent of 1/2. Remember, if it's not explicitly mentioned what the outer term is on the outside the root, it's assumed to be a 2. So this would be my simplified version. Over here, going to do the same thing. So this time I'm going to first take the cube root of 8, well, -8. When I do that, I end up seeing that that's going to be -2, because -2 times -2 times -2 gets me -8. The cube root stays with the x though. And then what I'm going to do is rewrite that as a exponent. So -2 x to the 1/3. Really quickly, I just want to remind you that when you have no parentheses, if you have your exponent written like this, you're only having it on the x. If I want to instead pull it out so this 1/3 was on both terms, I'd have to put parentheses like this to show that both the -8 and the x are experiencing the 1/3 radical, or 1/3 exponent. All right, over here. So I have my base term. There's nothing that I have to deal with, like no constants and coefficients. So it has a power of 3, and the root is 4. So I'm going to write that as 3 over 4. Remember, the numerator number is your power, and the denominator number is your root. All right, so if we go down here, we'll see the different exponent laws and the logarithm laws. And you'll see that it's essentially the same thing, which is why we wanted to kind of do a quick little recap of the exponential laws. So just like with the exponential laws, you multiply two terms with the same base, you're going to end up adding their exponents. Same thing here. If you have a log term of a base that's multiplying x and y, we can separate it as the log of the same base and then adding the x and y. The quotient rule basically works the same way. If we're dividing b to the x divided by b to the y, we're going to subtract x minus y. Over here, when it's log terms, we're just going to subtract log x and log y, again, of the same base. The power rule, it's going to work a little bit different than with logs. So here we multiply the x and y to get b x times y. Here, we're still kind of doing multiplication, except what we're going to do is pull the y out, and it's going to go in front of the log term, so that we're multiplying y times log of our x term. All right, so let's go down and do some practice questions with these. Oh, before we do that, just to recap. So they want us to think about this. If I just wrote x, what would the exponent be? Well, as we know, the exponent on a single variable like this is assumed to be 1. So x can also be rewritten as x to the 1. Not putting that exponent, we're assuming that it's going to be 1. I can ask the same thing. What would be the power, like what would be outside this root? Well, as I said before, if there's no number explicitly set outside the root, we're assuming it's 2. So the square root of x is could be assumed to be written as this as well. And then over here with log, using the same reasoning, what we're going to say is that if we don't have a base, so if we just leave it as log x, we're assuming that there's actually it's base 10 underneath. So in these practice questions, you'll notice that we've dropped the base. That's because we're assuming it's base 10 for this log term. But all the work would stay the same even if it was base and something else. All right. So just wanted to mention that in order to make life a little bit easier, we tend to simplify some of our log terms so that we're not constantly always writing bases underneath it. So for this, they want us to simplify this using the log rules. So again, multiplication of those two terms is going to turn into addition of the separate terms, so log 6 plus log 11. All right. Over here, we're dividing 6 and 11, so this actually just becomes log 6 minus log 11. Again, division goes with the subtraction, multiplication goes with addition. Over here, so this is actually going to be a few parts. So first, I have an exponent on the outside. So what I can do is I can use the power rule and rewrite this as 5 log 27 over 9. And then from here, I can do what I did in number 2 and subtract these two terms. So this becomes 5. I'm going to put big brackets, log 27 minus log 9. I need to make sure that the 5 stays in multiplied to both of these terms. So if you drop the parentheses that like I did, then the way you're writing it would make it seem that the 5 is only to the log 27. So just make sure that you keep the parentheses there. All right. Let's scroll down a bit. All right, so here, again, we can simplify some of these numbers, but we're not going to do it. We're going to just maintain the log rules. So here, what I'm going to do is first, I'm going to do the subtraction. So even though I have an exponent here, because it's not attached to both terms, I'm just going to ignore it for now. So I can rewrite this since this is division. This is going to relate to multiplication, subtraction. So I get log 2 to the 4th minus log 5. And then from here, I can do the power rule on this term. Since there's a 4 right here, I can put it in front, multiply it by log 2. And I'm going to leave it as minus log 5. Again, I did not put parentheses around this term because unlike before, the 4 is only attached to the 2. It's not going to be attached to the 5 as well. All right, so let's see. Now let's go to number 5. So here, pretty much the same thing as number 5. We're gonna, since the 6 is only attached to the y, I'm gonna ignore it for now and just rewrite this as log x minus log y to the 6th. And then from here, I can use the power rule to move the 6 in front of the log y. And I get this. Log x minus 6 log y. Okay. Scroll down. Again, you should start seeing the pattern and how it starts to become a little bit repetitive, but the more practice you do, the easier it'll be to kind of pull it out when you need it. All right, so again, the 4 is only on the u, so I'm going to ignore it for now. Log u to the 4th minus log v. I can now do the power rule, move the 4 in front of the log term, and I end up having 4 log u minus log v. All right. Number 7's a little bit trickier in the sense that we're not given the exponent right away. So we actually have to rewrite this as log xyz to the 1/3. Now, notice that I'm putting parentheses around the xyz because all 3 terms are underneath that cube root. So I need to make sure that I show that all 3 terms are experiencing the same exponent. So from here, I can do what I did before. Since this 1/3 power is related to both, I'm going to pull it out right from the beginning. Then from here, I'm multiplying all 3 of these terms. So I'm going to end up adding them. And again, I'm going to put big parentheses because I want to make sure to know that all 3 terms are going to be dealing with the 1/3. So log x plus log y plus log z. All right. So we'll do a few of the independent practices together. All right, so let's see. I'll probably do these 4. So here we're multiplying these 2 terms. So again, multiplication relates to addition. So this is log 5 plus log 3. Over here, we're going to do, because this exponent is only on the 2, I'm going to ignore it for now. And then I'm going to write it as log 3 plus log 2 to the 3rd. Because now I can deal with that exponent, so this becomes log 3. That 3 gets pulled out in front, multiplies with the log 2, and I get log 3 plus 3 log 2. One of the nice things is that you can plug these into your calculator and double check it. You could type in log 3 times 2 to the 3rd, and then type in log 3 plus 3 times log 2 in order to check to see if you're doing this right. All right. So these will be the last 2 that I do. So for this one, the 6 exponent is dealing with both terms. So I'm going to pull that out right from the beginning. So this ends up being 6 times log 6/5. Since we have division of these 2 terms, that means I can subtract them. And again, I'm going to put parentheses just to make sure that I remember that the 6 is multiplying both the log 6 and the log 5. Over here, same thing. I have that 2 exponent on both terms, so it's going to go out right from the beginning. So it's 2 log AB. I have multiplication between A and B, So that's going to be addition. And again, I put parentheses just to make sure that I remember that both terms are being multiplied by 2. All right, and that's pretty much it. So make sure that you continue working on the questions. Again, remember, make sure that you answer all the questions. Show me everything from the do now, guided practice, independent, and the homework enclosures. All right, if you have any questions, feel free to let me know. Join the Extra Help. Otherwise, good luck and have a great day.